Think of the opposite of a number in terms of a number line. The opposite of a number is the same distance from 0 as the original number, but on the opposite side of 0. So here, since -3 is 1, 2, 3 units to the left of 0, its opposite will be 3 units to the right of 0. 1, 2, 3, which is +3. So the opposite of -3 is +3. Notice that the opposite of a negative is a positive. To simplify in this problem, first simplify the absolute value of -5. Remember that the absolute value of any positive or negative integer is always positive. So the absolute value of -5 is +5. So we write +5 in parentheses below. Next, we bring down the negative from outside the absolute value. So we have negative parentheses 5, which is -5. So the negative absolute value of -5 is -5. If you need a review of absolute value, go back to section 1C in this chapter. In this problem, first simplify each absolute value. The absolute value of +9 is +9, and the absolute value of -4 is +4. Remember that we can use parentheses when we first get rid of the absolute value signs to avoid confusion. So here we have parentheses +9 and parentheses +4. Bringing down the negative, we have negative parentheses 9 multiplied times parentheses 4, or -9 times +4, which is -36.
Before taking the absolute value of a number, always simplify what's inside the absolute value as much as possible. So here we have 4 minus 10 inside the absolute value, which can be thought of as 4 plus -10 or -6. So we have the absolute value of -6, which is +6. To simplify this problem, the absolute value of 1/5 minus 1/3, we start by simplifying inside the absolute value. To subtract these two fractions, we need a common denominator. And the common denominator for 5 and 3 is 15. So we multiply top and bottom of this first fraction by 3, and top and bottom of the second fraction by 5. So we have the absolute value of 3 over 15 minus 5 over 15. Now we can subtract our fractions. 3/15 minus 5/15 is -2/15. So we have the absolute value of -2/15. And remember, the absolute value of a number is just the positive version of that number. So the absolute value of -2/15 is +2/15. Before graphing the combined inequality that you see here, we need to solve each of the two individual inequalities for x. So let's start with the one on the left. Our first step would be to distribute this -3 through the parentheses, which gives us 5 minus 6x minus 3 is greater than or equal to 14. Simplifying the left side one step further, 5 minus 3 is 2, so we have 2 minus 6x is greater than or equal to 14. Isolating the x term, we subtract 2 from both sides, and negative 6x is greater than or equal to 12. But watch out for your last step. To get x by itself, we would divide both sides by negative 6. But remember, if you divide both sides of an inequality by a negative number, you must switch the direction of the inequality sign. So we have x is less than or equal to negative 2. Over on the right, our first step would be to combine the x terms on the left side of the inequality by subtracting 4x from both sides. That leaves us with 5x is less than 15, and we divide both sides by 5, so x is less than 3. So we have x is less than or equal to negative 2, or x is less than 3. Now we have a situation that looks just like the problems in the previous section. Our next step would be to graph each of these two inequalities just above the number line so that we can see what's going on before we try to combine them. For x is less than or equal to negative 2, we have a closed dot at negative 2 and an arrow going to the left. For x is less than 3, we have an open dot at 3 and an arrow going to the left. Remember to use long arrows. Remember that OR represents union. And the union of these two inequalities means that our answer will include everything that's mentioned in the two inequalities. So all we have to do is bring both of these graphs down to the number line and see what we're left with. So we have x is less than or equal to negative 2, along with x is less than 3. If you take a look at what we're left with, we have the graph of x is less than 3 on the number line. So our answer reads, the set of all x's such that x is less than 3. Using the rule we learned in the previous example, we can solve the equation, the absolute value of 5 minus 2x equals 11, by first splitting things up into two separate equations. Our first equation will look exactly like the original, except for the absolute value signs. So we have 5 minus 2x equals 11. Our equations will be separated by the word OR, and our second equation will look exactly like the original, except for the absolute value signs, and we'll change this 11 to a negative 11. So we have 5 minus 2x equals negative 11. Now all we have to do is solve our two equations. On the left, subtract 5 from both sides to isolate the x term, and we get negative 2x equals 6. Divide both sides by negative 2, and x equals negative 3. On the right, we also subtract 5 from both sides to get negative 2x equals negative 16. Divide both sides by negative 2, and x equals 8. So we have x equals negative 3, or x equals 8. And that's our answer. For the problem you see here, it's very important to understand that before we can split things up into two separate inequalities, we must first isolate the absolute value on one side of the inequality. So our first step in this problem is to subtract 5 from both sides of the original inequality. That gives us negative absolute value of 6 minus 2c is less than or equal to negative 4. Next, we would divide both sides by negative 1. And watch out when dividing both sides of an inequality by a negative number. Remember, we must switch the direction of the inequality sign. So that gives us the absolute value of 6 minus 2c is greater than or equal to 4. Now we can split things up into two separate inequalities because we've isolated our absolute value. Our first inequality will look just like the original minus the absolute value signs. So that's 6 minus 2c is greater than or equal to 4. In our second inequality, we will switch the direction of the inequality sign and make the right side negative. So that's 6 minus 2c is less than or equal to negative 4. Since our absolute value inequality as it stands now uses a greater than or equal to sign, we use the word or between our two inequalities. Our next step would be to solve each of the inequalities for c. So on the left, we subtract 6 from both sides to get negative 2c is greater than or equal to negative 2. Then we would divide both sides by negative 2. And watch out again, when dividing both sides of an inequality by a negative, we must switch the direction of the inequality sign. So we have c is less than or equal to 1. On the right, subtract 6 from both sides to get negative 2c is less than or equal to negative 10. Divide both sides by negative 2. Again, switch the direction of the inequality sign to get c is greater than or equal to 5. Bring down the or. And on a number line, we would have a closed dot at 1 and an arrow going to the left for c is less than or equal to 1. And for c is greater than or equal to 5, we would have a closed dot at 5 and an arrow going to the right. So our final answer is the set of all c's such that c is less than or equal to 1 or c is greater than or equal to 5.